Hello everyone, welcome to the demo video of our social media performance tool. Okay, this is the pre-hackathon challenge, and here I am Yogeshwar Bule, and my team name is LangFlow. So I am excited to showcase how we have built a platform that simplifies social media engagement. So basically, in this video, we will walk you through the live demo of our tool. Then we will look into the engineering workflow. Then we will also talk about the LangFlow pipeline architectures, where we hosted our applications, what database we have used, and also talk about the dataset. So if someone doesn't know about the pre-hackathon assignment challenge, you can pause this video and you can see the problem statement on the screen. Now we will look into the live demo of our application. This is the first landing page of our application. Let's simply get started. This is the home page of our application, and the data that you see here, the post distribution, right? It's all about the engagement summary of our all posts, the post type, the post category type. Let's say if I check the travel, you can see how much engagement we get on fashion is around 28%. We can also filter out the date to see the engagement of our all post. Let's say if I select 1 December, 1st January, this is the engagement we get. Let me, and the average engagement by post wise, Urazole, Reels, Static, and average engagement by post category. On fashion, we get more engagement. Cool, right? Now let's chat with this data. Just simply click on the chat button. When you click on the send, the query will proceed within a second. Yes. Now we'll put one query. Compare the engagement rates of Reels versus static. Let's see how it will respond. Yes. The total engagement is 23,000 for Reels, and total engagement for static post is 3,000. Comparison based on the engagement rate calculation, Reels post have an average engagement rate is 68%, while static is 10%. The conclusion is Reels posts are more engaging than static post. This is how we get the data. So you can also simply press on download to get this conversation history. Now this is how our application demo looks like. Now let's understand what's happening behind the scene. So firstly, we will talk about the what are the tech stack that we use. For backend, we use Python. For frontend, we use Streamlit. For creating a workflow, we use LangFlow. Here we use Astra DB database, and we have hosted this application on AWS. Okay. Also, we have this data set. These data sets include real-time engagement data from the various media posts. Okay, we have integrated over more than 500 plus entries in this database. So this data is stored in the Astra DB and it retrieved dynamically during the analysis. Okay. Now we will look into the database setups. Here we use Astra DB as our database. Why Astra DB? Because it easy to use, built-in vector search features, and it's also scalable. So here we have created a media database in Astra DB. So this database is a vector database. A vector database stores vector embedding, which means which are the numerical representation of complex data. You can say text, images, videos. This embedding makes it easy to perform vector search. If I am trying to simplify the concept of vector search, let's say when you search a Reels engagement, the database doesn't just look for the exact matches. Okay, it looks similar concept to find the most relevant informations. Imagine if you ask or hit the query like what type of post gets the higher engagement. Instead of matching the exact question text, vector search retrieves the related post with the higher engagement by just understanding the meaning of our query. This is the meaning of vector search. So now let's discuss the LangFlow workflow pipeline. Here we have two pipeline. First, we will discuss the dataset preparation. So as you can see on the screen, here we have a option file upload. The pipeline process begins with the file upload component. What exactly the file upload component? Here we upload our dataset such as CSV file that contains social media engagement data. Okay, this datasets includes maybe raw data like post type, engagement metrics, likes, share, comments. Okay, whatever. Now, after uploading, the file passes into the split text component. Now, this component breaks the dataset into the manageable chunks for efficient processing of data. The chunks are now passed into the inject data. Okay. Now, this what happened here? Using embedding model, the text is converted into the vector embedding. What exactly means vector embedding? The numerical representation of the data. Finally, we will get the embedding stored data in the Astra DB. Okay. Now we will use this data for our efficient search. Now let's discuss the second pipeline. The second pipeline is the core component of our system. Let me start. We can start with the chat input. The process start with the chat input component. Here, user hit the query like compare the engagement rates of reels versus static images. And now these queries are sent into the pipeline for analysis. Okay. Now our query will go into the combined text. Combined text will receive input in the form of text or in the form of chat. What exactly will combined text will do for us? This component structure the entire query and provide clear instruction for AI to process it effectively. What happen after that? The process query is sent to the Astra DB. Now Astra DB retrieves relative embeddings from the database based on the whatever query that we hit. Okay. Now those data is sent into the parse data. Now parse data, what happened here? The data is converted into the plain text and making it ready for further processing. Now this retrieved data is passed to the OpenAI. Okay. Now here we have ChatGPT 4. It will process the data, performs calculation, comparison, and generates human readable insights here. For example, Reels generates 23% more likes than the static images. Okay. Now finally, the generated insights are passed to the chat output. This is how the entire workflow of our second pipeline. I hope you understand and thank you for watching my video.